As you can see, this will be the 2019 free response numbers 4, 5, and 6 for the Calculus AB exam. Please note that question number 4 is also a BC question, so if you're looking for BC question number 4, you're at the right video for that one. Okay, so let's go ahead and get started here. Let's start with question number 4. Question 4 says a cylindrical barrel with a radius of, with a diameter of 2 feet contains collected rainwater as shown in the figure above. So we have a cylindrical barrel. The diameter is 2 feet, so we want to be careful with that. That means the radius equals 1 foot. Right? The radius is 1 foot. And it says a cylindrical barrel with a diameter of 2 feet contains collected rainwater as shown in the figure above. So we have some water in here. All right, this is H, the height of our water. It says the water drains out through a valve not shown at the bottom of the barrel. The rate of change of the height of the water in the barrel with respect to T, all right, so remember this is number 4, they give us the H dt, the rate of change of the height of the barrel, is modeled by negative 1/10 root H. Feet per second. All right, so that's dH dt. And they also give us the volume of the cylinder with radius r and height h. They tell us the volume of the cylinder is pi r squared h. Part A says, find the rate of change of the volume. So they want us to find dV dt. Now this is a related rates problem, but before we panic over that, let's look at our picture and realize they've given us a gift. The radius of our container never changes. It's a cylinder. The radius is 1 foot from the top to the bottom. So we can come back here and we can rewrite our volume equation to being pi times 1 squared times h, or pi h. Unlike the problems where your cone is your container and you have a difference in radius as you move up and down, in this problem the College Board gave us a constant radius, so we can replace the radius with the constant 1, because that's what it is, and now we get a formula for V that's not very hard. Part A says find the rate of change of the volume of the water with respect to time when h is 4. Well, we can take this, we have the formula for the volume right here. So dV dt is equal to the derivative of this, which is going to be pi times dH dt. But we know dH dt. So that's going to be, they gave us that, that's going to be pi times negative 1 over 10 times the square root of h. And they asked us to evaluate this when h equals 4. So we get pi, negative 1/10, the square root of 4 is 2, so this is negative, right? Square root of 4 is 2, 2 into 10 is 5. This is negative pi over 5. And that's the rate of change of the volume, so that's cubic feet per minute. Right, I believe our units are here. Oh, sorry, seconds. Okay. So that's the answer to part A. So yes, it was a related rates problem, but it was a very nice related rates problem in the context of they did not allow, right, they did not allow the radius to change. Part B says, when the height of the water is 3 feet, all right, so part B is when h is 3, so that's a different time than we worked on here. When h is 3, Is the rate of change of the height of the water with respect to time increasing or decreasing? Now, to tell us something is increasing or decreasing in calculus class, you take its derivative. But we have to be careful with our vocabulary here. They asked us, is the rate of change of the volume, is the rate of change of the height increasing or decreasing? So we're checking to see we want to know is rate of change of height increasing or decreasing. Well, to find out if the rate of the change of the height is increasing or decreasing, we have to take the derivative of the rate of the change of the height. Because to find out if something's increasing or decreasing, you have to take its derivative. So I have to take the derivative of this. This is the rate of change of height. So I have to take the derivative of this. In other words, I have to find the derivative of dh dt. Now that's d2h dt squared, right? That's our symbol for the second derivative. Now we know how to find the derivative of that. That's going to equal, we're going to take the derivative of this, we're going to get negative 1/10. The power here is a half, so we bring down the half. 1/2 minus 1 gives us h to the minus half. So we have negative 1/20, and then the square root goes on the bottom. So this is our second derivative. And they want to know, is this increasing or decreasing when h is 3? So we're trying to treat the second derivative, right? The second derivative, that's telling me what's increasing or decreasing. Not because we've changed the rules, because we're asking about the increase or decrease of the first derivative. So they're really playing with the vocabulary here to make sure you understand your vocabulary. Tell me, is the first derivative increasing or decreasing? Okay. To tell us something's increasing or decreasing, I have to take its derivative. So you want to know about the first derivative? Yes, I do. Is it increasing or decreasing? Okay. So to do that, I have to take its derivative. But if I have the first derivative and I take another derivative, I get the second derivative. So we did that. And now what are we going to do? We're going to run a sign test. Now, what do we want to test? We want to find the second derivative when h equals 3. And we want to know, is this going to be positive or negative? If it's positive, it's increasing. If it's negative, it's decreasing. So what do we get? Right? What do we get? We want to do this when h equals 3.